Hey everyone, Nanish here, and today we are gonna go on treasure hunt. Not for gold, but for numbers. We are gonna look two ways to find particular number in given array or list. One will be linear search, second one will be binary search. Linear search is nothing but like go on each door and asking to that person, hey, are you the Nanish? No? Then are you the Nanish? Same we are gonna do in our code also. We will have one list of numbers where we will find our given number. Let's see in the code. Consider this is the array and you are gonna look for target that is 1 in this array. So if you use linear search to find out that, then first you will come over here and you will see, hey, is this 8? No. Then you will come here. Are you 8? Nope. Then are you? No man. Finally you will come here and you will check, oh, it seems like 8, and then you will return index of this number. If this number is not available here and if it is over here somewhere, then you will look entire array to find out your number. Pretty simple, right? Let's write code for this. So I'll write one method and I am returning int that will represent index of our number. So linear search, I'll take array as a parameter. Even though I am having here, I'll not use this one. I'll pass array and target from the method that gonna call. And in the code, as we are gonna check each and every element, we will use loop. Here I am taking for loop which will run till array's length. If you think for the logic, as you are just gonna see is your target meeting with the value of ith index, we will use simple if condition like this, and if it's there, you are simply gonna return I. If you didn't find anything, that means your target value is not available in the array, we will return -1. So that will be indicator that our target is not available. And all set. This is the code for linear search. If you see what we are doing here, using this while loop, we are iterating over entire array, and in this if condition, we are just checking is our target available in the array or not, and that's it. Pretty simple, right? But if you think with the perspective of time complexity, as we are iterating over entire array, this will take linear time. That means as size of input will grow, time required to iterate over it will also grow. In short, big of n. For this if condition, because this if is gonna execute for every iteration, this will also take n time, this return will also take n time, and this return will take constant time. So in totality, this entire method will take big of n time complexity. Let's call this linear search and see is it even working or not. So I'll create object of our search. Here we are calling our linear search method, and here we have to pass our array and target. So I'll cut that array and target from here and I'll pass to the function. After that, we just have to print the value in console. So code is completed for linear search. Let's run the code. Hey, we got the output. It is saying index 3. So let's see. For target 8, let's count this from 0. 0, 1, 2, 3, and yep, it's correct. 8 is available at index 3. We will cross check with another value also. So I'm searching for 18, and if I am correct, answer should be 8. Let's run again, and yep, this time we got index 8. Means our code is working fine. If you see the code, it's very simple. We are not doing anything, we are just iterating over the array. Pretty simple, right? But there is one downside for this algorithm, that is its time complexity. We have another algorithm called binary search that is famous for its big brain power. But before that, here is one question for you. Quick brain check. Suppose my list or array contains 100 element and the number which I want to find, it is available at 100th position. How many checks will my linear search will do? If you know the answer, write it down in comment section. Well, it is 100 only, right? Because linear search gonna check each and every element. Now let's see binary search. So I'll write one function for it. I'll return int also for index, and I'll take array and target as a parameter, not array of target. Here we need two variables. One is left, whose default value gonna be 0, and one will be right, whose default value will be array.length -1. And to iterate over our array, I'll take one loop, but here I will take while loop, and my condition to break the while loop will be like this. So if my left is greater than right, then I will break the loop. Here I will take one more variable, that will be mid, and value for mid will be this, left plus right by 2. Why? Let us understand that. So this is my array and target. I'll just paste it here so that we can understand better. And for target I will take 8. So if you think, at first time value for left is 0, that means it is holding index for number 2, so first element, whereas the right variable will hold the value that is at the end of your array. If you see and if you do the calculation, output of this gonna be 4.5, but because I am taking this into int, it will get converted into 4. After that I'll simply check array of mid is equal to my target or not. If it's equal, that means I got my result, and I'll simply return mid, which is index. If it is not equal, what I'll do, I'll check is array of mid greater than to my target or it is less than to my target. Obviously it will either be greater or less, right? Here I am checking is array of mid is greater to my target or not. If it's greater, that means, see over here, right is pointing over here, left is pointing over here, and mid is pointing over here. Now my target is 8, that means my target is less than my array of mid, correct? So over here what we have to do, our right that is currently pointing on 19, he should be point to 10, or you can say 8 also. We will understand this in details while debugging the code. So first I'll change the position of right by mid minus 1, and if it is not greater than target, then I'll change position of left to mid plus 1. And if my loop is getting break without finding my mid, that means my target value is not available into array, so I'll simply return -1. Now let us understand this code little bit in detail with debugging. So for that, first I'll call this method. So object of search we are already having, so I'll directly call over here. And I'll pass array and target. And I'll simply print this value. So to print, I need to write console.writeLine index. What I'll do, just for better understanding, I'll print it like this. Okay. So debugger pointer I'll remove from here, and it is set on mid. So let's debug this code. Okay. We have come on debugger point, and if you see over here, because this is first iteration, left is holding value 0 and right that is holding value 9. 9 means it is indexed for value 19. And if you see output for mid, it is 4. And if you calculate, your 4 index will point to the value 10. Now here we are checking is array of mid equal to our target or not. Obviously it is not, because array of mid is pointing to 10 and our target is 8. Okay, I think I said target 2. Let me check. Yeah, our target is 2. Okay, so let's solve this for 2. So think, is our array of mid greater than target or less than target? Array of mid is pointing to 10, whereas target is 2. So obviously it is greater than target. And because it is greater than target, over here where my right is pointing over 19, I'll make my right to point over 8, and that is what we are doing on this line. And if I continue and if I came for second iteration, you can see value of left that is 0 and value of right that is 3. So 3 means it is pointing for value 8. Obviously it is not equal to target, so we will fail over there. It is array of mid is still greater than target, so we are again gonna change position for right, and we are again gonna do same process. This time also, because our left that is still pointing to 0 and right that is also pointing to 0, and that means our mid is also 0. On index number 0 we are having our target value 2. and now we will return our index. So if you see here, so this is our output, index 0. We'll see this for one more example. This time I will change the target. I'll make target as 8 and we will run. As this is first iteration, value of left and right should be the default values, that is 0 and 9 obviously. Now below operations we already know, so I'll make it continue directly. Now we came for second iteration. In second iteration, value of left, it is still 0, but right is pointing to index 3. That means 0, I'll see over here, 0, 1, 2, 3. That means it is pointing for 8. And our target is also 8, but we are not checking our target on left or right. We are checking our target against mid. And mid, if you see the updated calculation, it is pointing to index 1, that means 4, and 4 is not equal to 8. So this if will gonna fail, and we will check now is array of mid is greater than target or not. This time it is not, and we will come into else condition, and here we are updating value of left instead of right. I'll make it continue, and now if you see, value of left is 2 and value of right is 3. So in the code, left is pointing to 6 and right is pointing to 8. Mid this time is pointing to index 2, that means 6 only. So obviously our target check gonna fail, and we are gonna check is array of mid greater than or target or not. It is not, so we will update value of left. If I make it continue and see the last iteration and check the value of left, right and mid, left is pointing to 3, right is also pointing to 3, mid, if you do the calculation, it will also point to 3 only, and 3 means 8, that is our target. So this time this if block should be success, and wow, it got success. And finally we got our mid. If you see on terminal, you should have got your index 3, you can see here. So we got our output. One thing you might have noticed that is different for binary search, that is array for binary search should have been sorted only. You can't do operation on binary search with unsorted array. Why? You might have guessed over here. We are skipping entire subset of array based on it is greater than or smaller. Whereas for linear search, it doesn't matter. It is gonna check each and every element, so there is no necessity of sorting. But for binary search, it has to be sorted only. And if you think for time complexity perspective, for binary search, it is big of log n. Whereas for linear search, it was big of n. Why big of log n for binary search? See over here. Our target, that was 8. And at initial time we were having 2 for left and this 19 for right. What we did, we calculated midpoint, and we saw this mid is greater than to our target or not. It was greater, so there is no meaning of searching into this entire block, because this is sorted array. We can skip this entire subset and we just have to look into this much part. So the updated scope, you can say, is this much only this much. Whereas in second iteration we got our mid value, that is 4, and this time our target was greater than mid. We updated value of left, and our updated scope that become even half of our current array, and same gonna be happen till the time you didn't find your end. So if you notice, at every iteration our scope is getting reduced to half, and that's why it is big of log n. Understand? As we already have learned recursion and now we have learned binary search as well, we will implement binary search with the help of recursion. So if you see, I'll have one more method for binary search with recursion. That method will also return 8 for index, and this time I'll not only pass array and target, but also I'll pass positioning of left and right. Why? Think guys, here because this was while loop, we were able to calculate left and right and assign the value there only. But here we don't have any loop. Our loop is our recursion call itself. So what we can do here, we can calculate that value, and when we are passing our recursion function, at that time we will pass value of left and right. We'll see that. So in recursion, you might have recall, first we need base condition to exit our recursion loop. So I'll take that And here our base condition wanna be same as we were having for while loop. So left, if left is greater than right, that means we didn't find our loop. See over here, our while loop was running till less than equal to right. If it is greater than, we were returning -1. Same we will do over here also. We will return -1. If not, we will first calculate mid and we will check is our target, is our array of mid same to target or not. If it's same, that means all set, you got your answer. But if not, then you have to check is it bigger than target or not. So we'll check is it bigger than target or not. If it's bigger, we will call this recursion function again. And we will pass array target. And for positioning of left and right, remember guys, what we were doing in our iterative option, if our target is greater than array of mid, we were updating value of right. Same we will do over here. For value of left, we will let it have as it is, and for right, we will update it to mid -1. Whereas for else part, we will update value of left instead of right. So we will pass right as it is, and left gonna be switch for mid +1. Now you just have to call this function from our main function and let's return whatever value we are getting from binary search recursion. Here also we have to pass array and target. And for left and right, we have to pass our default values. Remember what we were having for left, it was 0 for left, and for right it was array of length -1. Let's run this and let's see what is the output. And we got index 3, same output that we got with our iterative approach. Before signing off, here is one question for you. Which searching algorithm will you use to find your crush data in your college data? Write it down in the comment section. If you didn't understand anything, write it down in comment. I'll take those points in next video. Hit like button and subscribe button. We'll meet into next video. So this is Nanesh signing off. Code smart, stay curious.